Hey, hi there. My name is Rustybot. These are hand thrusters, and I'm going to show you how to make your own. In order to get started, I have a little project kit template available in my public folder, the link for which will be in the description, and you just spawn that out and then you can follow along with the rest of the video. So here's the starter kit, but before we begin touching that, we're going to move over a little and just open browse nodes and start trying to apply force to ourselves. In order to do that, we need to go into physics and apply character force. Nice and easy. The way this node works is it has a pulse that goes through it. So you call it based on an event. It has a force to apply. So this is going to be a vector that you scale based on how hard you want it to push. It has a check for ignoring mass or not, which we are going to do. And it has a character input, which just sort of gives you a generic field. We want to be able to find this from ourselves. So I'm going to go over here to find character controller from user. This takes a user input and outputs a character controller data type, which we can plug in here. So this is essentially what handles your physics. We're going to put a user in here, which is a direct reference to a person, and get a physics controller out here from that person. So in this case, we're going to go back to down here, users. We're going to get active user and plug that in. And now this is a slot, which we can use an input for. Now just select any random part of yourself. I'll just use the root of my hand, put that in there. And you'll notice when you do that the output of this active user slot, if I make a relay there and then delete it real quick, is me. That's my hand. It's getting the active user of that hand. That's me. It's finding a character controller, and it's going to try to apply force to it. If I click that, the pulse goes through, but obviously it's applying 0 force, which doesn't do much. So I'm going to set that to 10. And now whenever I click this, it applies 10 force. This is actually in newtons. So if you know anything about physics, that's the basic force application unit. When you call this, it applies 10 newtons to you over 1 frame. What I've done here is set this to 0, 10, 0, which is 10 units up, so 10 newtons directly upwards. Each time I press this, it just pushes me a teeny tiny little bit. What we're looking for is something that applies force constantly. Now, what's important to remember is that since this is a computer, we're in a game engine, constantly just means every frame. So if I'm looking for something that activates every frame, I'm going to go back and I'm going to go to flow, and I'm going to get a fire while true. So this takes a condition, a Boolean, that is either true or false, has an output of a pulse. I'm going to turn on skip if null so that it doesn't keep firing if there's nobody in there. And I'm going to use myself as the updating user. So I drop this here, and then I'm going to click drive. And now there I am. There's the pulse output, and if I click this, it starts activating. So now if I plug this in here, now I'm going to make sure I hold this so I don't lose it by getting shoved up too far. But if I click this, I'm now getting constantly shoved upwards. This is the basis for how the thruster works. It just pushes you in a direction while a Boolean is true. Now a hand thruster that feels good is obviously not just on or off. You also have some play to it. In order to get that analog thrust level, we're going to get the trigger strength from our controller, which means going into devices and then controllers and then standard controller and taking one of the outputs here. These are all of the standardized buttons that every controller has access to. In this case, I'm going to be looking at primary, and I'm going to need to tell the node who to pay attention to and which hand to pay attention to. So I'll just use my left, and for user, I'll just plug this into active user of my hand, which is me. So now when I click primary, which is trigger, like that, it turns true. And when I let go, it turns false. If I pull out a display for strength, that's how much I'm pressing my trigger. So as I squeeze harder, it goes up to 1. And then when I click, it goes to true. If I let go completely, it goes to 0. If I try to hold it at roughly halfway, you can see I'm at about 0.5. And this is going to let us modulate our thrust amount. So I'll get rid of these real quick. And we'll start plugging stuff in. move this over here now that we're expanding our network. There we go. Firewall true and standard controller. I could just hook this up to primary and then get rid of the input. And now when I click trigger, it pushes me up. Like, pull out a display to make this more obvious. But like I said, I would like something a little more analog. In this case, that means going back out to the root here and then going into operators and getting mul, which is short for multiplication. So I'm going to plug strength and my float 3 input together into this, and then plug that into apply character force. Now, this isn't going to do anything yet, because as I pull my trigger towards 1, there, full strength, I still haven't clicked it in. So now when I click it in, it's just going to apply the full amount of force, which means we need to change this Boolean from primary to something different. In this case, I'm going to use when the strength is greater than 0. So that means just going back out to operators and getting greater than. I'll plug that into strength here, into the top input. So when the strength is greater than 0, this will be true, like so. If I squeeze it even just a little, that turns true. And I'll just plug that into my firewall true. So now, if I squeeze my trigger just a touch, it pushes me up just a touch. And if I squeeze it down all the way, I go faster. That's good. I can now modulate how much thrust I'm applying. If I currently take this float 3 input and put a 10 in the X instead, then it'll push me to the right. If I put a 10 in the Z, it'll push me forward when I press trigger. Ideally, this can be manipulated by some sort of reference object. I'm going to just use my hand. So I'm going to select that. I'm going to go to my hand here, and I'm going to look at the gizmo and notice that I have the X going off to the right, the Y going up, and the Z going forward. So in this case, I'm going to try and make the thrust come out of my palm, so that if I do this, I push away and I would move backwards, which means pointing in the up direction. So I'm going to go over here using my flux tool to transform, scroll down a little, direction, get up. That's this. It has a slot input and it has a float 3 output. Right now there's nothing in there, so it's outputting global up, which is 0, 1, 0. I'm going to grab my hand reference, drop that in there, and now it's displaying my hand's up direction in global space. So if I hold it mostly flat, you can see this is roughly 0.99, pretty close to 1. If I hold this upside down, now it's pretty close to -1. So what I can do is take this get up and just plug that in there, and now when I hold trigger, I'm moved very slightly in the direction my hand is pointing upwards. In order to illustrate this better, I can take this wire over to a little arrow that I prepared, and you can see that the up vector of my hand is what the arrow is copying. So this is the direction I'm going to be putting my thrust in. I can delete that and go back over here. I'm going to take this get up, delete the float 3 input, integrate these into the circuit, and now I want the ability to multiply this by some amount so that I can alter how much force is being applied to me, because right now full trigger strength barely pushes me anywhere. So in order to do that, I'm going to go back to operators over here, go to multi-mul, put the strength in and plug that in here. And then this manual input can be our thrust strength. So again, currently, this is full trigger strength. Basically nothing. You can see it working away there. Hold down trigger, nothing. If I set this to 10, it's now going to push me with 10 times as much force. When I hold trigger, now I move a little. In order to successfully complete this project, we're going to need to add a little bit extra. And that means using the project kit in the public folder. So if I take these nodes that it comes with, we have a value field drive, which controls some visuals that I have set up, and we have a playback drive, which controls audio that I have set up. We're going to take this value and connect it to strength, and also connect strength to the speed of the playback drive. Then we're going to take both play and loop and connect them up to our main control boolean. And now, when I press trigger, it activates some of the things that the cone has inside of it. The final step is to take the cone, which is called hand thruster parts, open up our hand here, grab the cone and reparent it to the hand, double click that and reset all the transformations. And now when I click trigger, this can act as the thruster. You can position this however you want. I'm going to move mine a little bit forward. There we go. And now as I push around, there's a bit more of an indication that something is happening. The rest of this hand thruster system here can be simply moved into place like so. Make that display up there. And these can become part of our circuit. So now what I'm looking for is a way to turn it on and off, because we've got visuals, we've got audio, but there's no toggle. And toggle is exactly the right word. So I'm going to go into flow. I'm going to get a data model Boolean toggle. That's this from the last video. When a pulse goes in the bottom here, this gets toggled between true and false. What we're going to be doing is triggering that off of a fire on true, connected up to a user, a condition, and then an output. Only for user locks it to one person firing. So if I plug myself into here, this will fire on true only for me. No one else will pulse that. This is important because if you leave it blank, then it'll pulse off everybody. It'll do it locally. So since this is an avatar system, I'm just going to leave it like so. The Boolean I want it to fire off of, in my case, is secondary. So when I press secondary, that gets set to true. When I let go, it's set to false. Now, whenever I press secondary, I get a pulse, and this is going to be my toggle. So when I put this here, when I press secondary, it's now true, and I'll press it again, and it's set to false. This is how I turn my thruster on and off. The problem, of course, being, how do you combine these two bools? We need it to operate off of both this one and this one. Again, and is exactly the right word. So I'm going to delete those, go back to operators, Boolean, and. This is a Boolean operation. It will be true as long as both inputs are true, and it will be false if it's in any other state. So as long as this is true and this is true, this will be true. Meaning I can take this, plug it into both the Boolean latch and the greater than, and then use that to drive the fire while true, the loop, the play, and the main display here. So now when I press secondary, this toggles, and when I'm pressing trigger, this toggles. Secondary, 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 and slightly holding trigger. There we go. Now if I press secondary, even though I'm holding trigger, that doesn't matter. But we've still got our particles coming out, which means we're going to need to add a conditional. So that's back out here. Conditional in operators. Value conditional, any variety. We're going to use this and to control it. That's the bottom input. And we're going to let the strength through when it's true and nothing through when it's false. So if the system is off, like so, pressing trigger does nothing. Well, it will do nothing once I plug this in. But currently, there's no thrust being applied. When I press secondary, that's now true. And now there is thrust being applied, so this is correct behavior. When I plug the conditional instead of raw strength into both value and speed, that's correct. Press secondary to toggle, nothing. So we're good. Now this is a little messy, and this is another thing that comes with Flux, is you gotta learn how to organize, because your circuits will end up going all over the place, and if you're the one who has to unpack and read them later, you're gonna wish you organized earlier. So I'll move this display over here, put some of this up there. That's a little better already. This is our main control, and this is our main control bool. So that's the toggle for whether the system's on or off. This is whether or not trigger is happening. This is actually applying the physics. This is controlling the visuals and audio. There we go. Now we can turn the system on and off. It's got visuals and audio. We can control the direction. All that's left is to fully integrate it. And that means packing it up. So in hand thruster system, I've got scripts and I've got flight, which currently only has those nodes from earlier. But again, I can grab flight, hold secondary on all this, pack it in there, and then I can take flight or the whole hand thruster system scripts setup, inspect myself with it, go all the way to avatar root. So for you, that is just under your user root slot. You've got your avatar somewhere in there. And if I take hand thruster system and drop that, I'm done. You can adjust this visual however you like. So for example, if I select this and you don't want the cone, you can turn that off and then deselect. And that's that. You have now integrated into your palm a hand thruster that you can use to fly around. Congrats on your first superpower.